All right, so this one pretty quick. This is actually our last video for Unit 4, titled Chemical Reactions. And this one is called 4.3, Predicting Chemical Reactions. Predicting Chemical Reactions. So we are actually going to predict what the products are going to be in a chemical reaction. So I'm going to go ahead and just write up two reactants, maybe that we would put together inside of a beaker. And we're going to go ahead and try to determine what the products would be of their combination. So let's work with, let's see, potassium chloride. And we're going to add that to iron, let's say iron oxide. Okay, and we want to know what we're going to get on the opposite side. Now, the way to approach this is to what I say, well, first of all, this is a double replacement reaction. So I'm going to have you predict two types of reactions in this video, and they're going to be either a double replacement reaction or they're going to be a combustion reaction. It's pretty easy to tell the difference because a combustion reaction would have O2 as one of the reactants. Now, in this particular reaction, let's back up here. In this particular reaction, we don't have O2. All right, I got to write that over again because I just erased that. So let's go K. Let's see, potassium chloride, again, plus iron oxide. So this is a double replacement. And if we recall, what happens in a double replacement is we kind of have the switching of partners, right? So if we think about potassium and iron as being the metals, and then we think about oxygen and chlorine as being the nonmetals, they're going to switch. So iron is going to pair up with chlorine, and potassium will pair up with oxygen. So in order to figure out how that works, what I ask you to do is go ahead and explode both compounds. Here's what I mean by that. I want you to write the ions. So potassium is got a 1 plus charge, and chlorine has a 1 negative charge. Okay. Now, iron and oxygen, this one's really tricky. I'm going to actually go to the box for this one. Okay, split it down the middle. All right, iron's a transition metal, so we do not know what the charge on iron is. While oxygen, though, has been 2 negative pretty much all the time for us. So iron, in order for it to be equal and opposite, and there's only one iron and one oxygen, iron must have a 2 plus charge. Okay. So my box tells me that the charge on iron is 2 plus, and we know the charge on oxygen is 2 minus. So I'm just going to clean that up here. Okay, so we have, let's see, Fe with a 2 plus. Okay, and then we have oxygen with a 2 minus. All right, so the concept here is that we're switching partners, right? Potassium is going to hang out with oxygen, and chlorine is going to hang out with iron. All right, so I'm going to write my products actually down on the, let's see, let's write right here. We can go, I think I've got enough space. So let's go, potassium and oxygen. Now, potassium has got a plus charge, plus 1 charge, and oxygen has a 2 negative charge. Okay, so what happens when we crisscross those charges, or what happens when we draw the box? So let's go draw the box for potassium and oxygen. Okay, we got potassium here. We've got oxygen here. All right, so in order to make them equal and opposite, I'll need a second potassium. Okay, now we're equal and opposite. So I've got 2 potassiums for every 1 oxygen. Okay, that gives me my first, actually going to shorten this up. That gives me my first product, 2 potassiums for every 1 oxygen. Okay, so that's good. All right, now the second thing, let me erase this guy, is to combine the iron and the chlorine. Okay, the iron and the chlorine. Now, let's see, iron has a 2 plus charge. Chlorine has a 1 minus charge. So again, if you want to draw your box, you could go and do that, but after you're done, you should notice that we've got 1 iron for every 2 chlorines. Okay, for every 2 chlorines. So this would be my equation. Okay, I've just predicted the products. I've switched the partners. And in order to do that and effectively switch the partners, I had to make sure that I exploded my reactants. Okay, so I opened them up. I looked at their charges. I switched the ions. and then I reconfigured what the actual subscripts should be. So we're not just carrying subscripts from one side of the reaction to the other. And this happens to be my overall reaction. Now you're probably thinking, oh great, but it's not balanced. Well, let's go ahead and balance it. Let's see, 2 potassiums and 2 chlorines. It's a pretty simple one to balance. Put a 2 out there. Okay, so to clean it up a little bit, you have 2 KCl plus iron oxide, iron 2 oxide, and that will give us potassium oxide plus iron chloride. All right. Now I do have an example one here that I want you to try to do. So if you want to look at this, write it down and pause the video and try this on your own. All right, so hopefully you tried it. Let's take a look. Again, we want to explode both compounds. So calcium chloride, oops, let me go back. Okay, calcium Ca has got a 2+ charge. Chlorine has a 1 negative charge. All right, and then let's go to the other, iron nitrate. Iron, if you did this correctly, iron has a 2+ charge. All right, and the nitrate, by memory, because it's one of your polyatomics, has a 1 negative charge. All right, now we want to switch pairs, remember? Okay, so your products are going to be the combination of the switched pairs. So calcium is now going to pair up with the nitrate. Okay, so we're going to have, let's go down here, calcium, and I want to combine that with my nitrate. All right, and then we're also going to have iron combined with chlorine. I think that looks familiar. We did that before. All right, and then my chlorine. Good. And you can go ahead and draw your boxes again if you like your boxes, or crisscross your superscripts, whichever works easiest for you. And when you do that, you should be coming up with the final 2 products, which are calcium nitrate and iron chloride, iron 2 chloride. All right, awesome. Now, we want to make sure that this is balanced, and it actually looks like it is. I've got 1 calcium here, 1 here, an iron there, 2 chlorines there, 2 chlorines there, 2 nitrates there, 2 nitrates there. So it looks like we are all good to go. All right, so hopefully you came up with calcium nitrate and iron 2 chloride for the 2 products. All right, now combustion reactions, these are actually a little bit easier, believe it or not. If you have any combustion reaction, so let's just put the combustion of ethane up here. Okay, I know it's a combustion because oxygen is one of my products. Okay, and I'm only going to give you guys combustion reactions that include what we call a hydrocarbon. Okay, so if you break down that word hydrocarbon, I think you might understand that that particular substance includes hydrogen and includes carbon. Okay, it's a hydrocarbon. All right, so in this case, if you've got oxygen combining with the hydrocarbon, you're going to have 2 products. You're going to have carbon dioxide, and you're going to have water. So really, the only thing that you've got to remember here, you don't have to worry about switching ions, you don't have to worry about switching partners or worrying about oxidation states. All you've got to do is memorize that for a combustion reaction with a hydrocarbon, the 2 reactants are carbon dioxide and water. And then obviously from here, if you're savvy at it, you would go ahead and balance this equation. I'm not going to do that for you here. You can do that on your own. And you'd come up with a solid chemical reaction. So on a worksheet, you might see something like this, and it would ask you to predict the products and then balance the equation. And hopefully you've got the ability to do that now. All right, that's 4.3.